All right. Hey guys, we're going to be talking about the key features of a function. So what that means is I've got a line. Like last video, we talked about, well, where is the graph? Like, where does it cover? X values, Y values, what does it have? Today we're going to be going a little bit more in depth with that. We're going to be talking about, well, where are the X values? Like, where does this graph go up? Where does it go down? This is a really big deal in like stock market. If you want to be really smart about your investments in the future, like being able to think like this is pretty important. So let's get started. One big thing that we can talk about with functions is, well, where do they intercept our axes? So I would look here and I'd be like, well, they intercept my axis at -7 and 6. So that's just what I would say. -7 and, not -6, 6. So there's my ordered pairs, my x-intercepts. So that's a feature of the function. Where does it cross the x-axis? Right there, okay? This graph wasn't originally meant for the question of where's the y-intercept. So I know that's like 2 1/4-ish or something, but we're just going to say our y-intercept is -2. So 0, -2-ish, right? Because it's just for the sake of it. I know you know what the y-intercept is. Okay, if you're asked about the y-intercept, I promise it will be on a nice number that you don't have to approximate or anything. The big thing for this graph that we're going to talk about here is, where is the graph positive? AKA, where are the y values positive? And where are the y values negative? So I'm going to do red and blue for light side and dark side. Where is it positive? If my y values are positive, well, that's up here, right? My y values are going to be negative. Let's see, down here. So if I'm looking at where the graph is negative, well, that's going to be all this stuff. Everywhere below the x-axis. And I think that's what your official definition is on your vocabulary page. Negative is where the graph is below the x-axis, aka where the y values are negative. Positive is where the graph is positive, or where the y values are positive. So it's really easy for us to highlight and say, that's where it's negative, that's where it's positive, and that's great, but we need to be able to say that, okay? And there are 2 different ways to say this. We can use inequality notation, which we have been using. Okay, that's the less thans, greater thans, less than or equal to's, greater than or equal to's. Okay, open circle, close circle. There is also another notation, which frankly is a little bit easier in these cases. And so I'm going to show both and you'll decide which one you like best. Okay, we've done inequality more, so maybe you're going to end up being more comfortable with that. But interval is what it's called, interval notation. It doesn't require an x or a y in the middle. Okay, so with interval notation, we're going to look at the infinity symbol, which hopefully you know what that means. It means forever. And this means or. It's like a big U. Here, if I scroll down just a little bit, it's a button on your Delta Math, okay? When we're doing inequalities, we use the word or, which you did last unit, right? It was, ors and ands in compound inequalities. We're not doing compound inequalities, but like the notation follows. If we're doing inequalities, you use the word or. But if we're using interval notation, that symbol means or. Okay? Interval notation means when it's an open circle, we'll do it like that, then it is, I'll do like below or something like that, or above. When it's an open circle, we use parentheses, or we call them soft brackets, meaning, remember, open circle means it's like not including that number, it's open, okay? So soft brackets means like this is like our soft barrier. We're not going across these lines, but it's not like set in stone. kind of thing. Like, think about it that way. That's not exactly what it means, but think about it like that. Closed circle means hard brackets. This is my hard stop. We stop right there, okay? And you can mix and match them depending on if it's open or closed, okay? While we're here, I will say no matter what, infinities have to use parentheses. Okay, so we'll see what that does, okay? So, now that we've talked about notation, sorry that took so long. Let's get back to positive and negative. It is positive, like my blue highlighting started at 6. So that is going to be where we start. I'm going to start with interval notation, okay? We're starting with 6, and then my arrow, we're going to pretend that goes back up for the sake of this example. That arrow goes on forever. Arrows mean forever. They mean infinities. So even though the graph stops at 9, the graph doesn't actually stop at 9. That's just how much Delta Math is willing to show you. Okay? That goes to infinity. So we're going to say it's positive from 6 to infinity and beyond, right? If I were saying this in inequality notation, I would be saying, well, everything bigger than 6. X is greater than 6. Okay. X values. Should we add that? We always do X values. Negative, when it's negative, well, I'm starting down here. We always go left to right. So my most left negative spot is, well, negative infinity. And then my graph goes and goes and goes, and it stops being negative at 6. Okay, in inequality notation, that's everything less than 6. So those are your two options, okay? I'm going to go through it with just interval notation because I know that's the new thing. And then I'll pause the video and write the inequality notation so that you can still see both, but I'm not going to spend a ton of time explaining both, okay? Yeah, let's try it out. Okay. If there's a line under the symbol, then you put a line under the symbol, aka you use the hard brackets, or less than or equal to, greater than or equal to. If I'm talking about everything less than 0, that is going to be negative numbers. Hopefully that feels good to you. It should, because all the numbers less than 0 are negative numbers. So I'm going to go here and I'm going to say, okay, it's negative. Like that. Okay. So that means negative infinity to negative 8. So here's where it comes in, right? I've said earlier, infinities always use parentheses, no matter what. We're going to use hard brackets for everything else because of that right there. But infinities, it's like the Trump rule, that goes above the hard bracket, soft bracket rule. Okay. So soft bracket on the infinity, hard bracket on the negative 8 because that's a hard stop because of these symbols. And let's just keep going. Okay, or, because I'm using interval notation, I'm going to use that or, not this one. Negative 4, comma, all the way to 8. And that's what I'd put in the answer box. And there's your inequality notation. Shall we try again? Okay, now we're going positive, right? That's greater than or equal to 0, so that means positive using the hard brackets or equal to symbols. So I want positive. I'm switching back to my blue. Everything's positive here, and then this last little tail. So again, we can highlight it all day long, but that's not what Delta Math wants. I mean, we can say that. So, but I need to be able to write it on my answer box. So again, we're going to do interval notation because that's new. We're going to start at hard bracket negative 8 to 4 because that's where we go. And then hard bracket 7 to infinity and beyond. Infinities always use parentheses, no matter what. We do that because a hard bracket is something that you can stop right on, right? I am right on 7, and I can physically see 7. Infinity is this unreachable foreverness. We can't have a hard stop on infinity because there's no stopping. So we have to have that soft bracket saying it's not certain kind of thing. Okay? There's an equality notation. Okay. Extra thing. When it says negative, that means all soft brackets. No equal to's. Okay? So if I want where it's negative, that is where it is below the x-axis. So it's that piece right there. And that is just -9 to -1. Everything's soft because it said negative. Okay, that's just how delta math is coded. Okay. No line under it. Try again. Again, negative. We're going to switch it to positive so that we can see that. Positive is everything above. And notice I'm going to lift my pen and I'm going to start again over here. So I highlighted 2 pieces. I'm going to have to write 2 pieces. So that is going to be, I know it's going up, but that arrow is going to the left. That is negative infinity to -1, or 3 to positive infinity. They used no line under the symbol, so you don't use a line under the symbol. This is going to be parentheses and or these 2. Okay, so we're going to say x is less than -1 or x is greater than 3. Okay, again, I know it's going up, but we are looking at the x values, right? That's what we're writing down here, the 1 and the 3. If I'm looking at x values, this is going to the left. That is negative infinity. So that's why we put a negative infinity there, even though it's going up. Okay, I know this is a long video and I'm sorry. Put me on 2 times speed if you haven't already. Okay, the other few things we can talk about. We can talk about, well, the peaks, and we can talk about the valleys, essentially, of the graph. If we're talking about the stock market, that's the biggest deal, right? You want to sell up here when your stock is worth the most. You want to buy the stocks down here where it's worth the least so that you make all that money. So let's talk about it. A relative maximum is just any peak. It doesn't have to be the tallest peak. And when we're doing these, we only talk about the y values. This is the only time we ever only talk about the y values. When we go to increasing, decreasing, we're going to go back to x values like we were before. Okay, my maximums, all my peaks, right here. I care about the y values. This y value is probably our trickiest, right? That is 0. This one is -2. This one is 5. And then the absolute maximum is the absolute highest. So it's going to be 5. Relative minimum, I'll switch colors to purple, are all my valleys. Okay, so only when it goes down and comes back up. So I know this graph is like going down, but we only care about when it's an actual valley, like it goes down and comes back up, makes a little valley. Okay, that is -5 and -6, and my absolute minimum, the absolute lowest, is -6. So that one again is probably on the easier side. Let's talk about increasing, decreasing. Increasing, decreasing, first of all, always soft. Always parentheses. You're never using the hard brackets, okay? So that's kind of nice. All right, we're talking about increasing, decreasing. Sorry, I had to pause the video, so I hope I'm starting off in the right spot. We're talking about increasing, decreasing. It is going to be x values like we did positive and negative. But this time you're never going to have to figure out which symbols to use. It's always parentheses, always no line under the symbol. Now, increasing, hopefully, is going to sound right. It's where the graph is increasing. So if we're talking about the stock market again, it's where you're making money. Okay, your money is increasing. The formal math definition is it's where the slope is increasing. So notice if I drew like a straight line right here, you know, hitting this one, like trying to kind of line it up, it would be a positive slope. Okay. Decreasing is when you're losing money, when your money is decreasing, or when the slope is negative. So then we have to write all that. Let's start with increasing. That is going to be negative infinity to -7, and then -3 to -1, so that's this blue piece, and then 4, looks like I drew a lot right there. Yeah, 4 to 7. Notice all x values. I mean, yes, it's high up here. That's 5. That's great. We don't care. We're talking about x values. Decreasing. Decreasing is going to be all the red, or you know where I erased it by accident. There we go. So -7 to -3, -1 to 4, and 7. So now the question is this infinity or negative infinity? And the answer is we are talking about x values. So I don't care that it's going down, I care that it's going to the right. So that is going to be 7 to positive infinity. Okay, I'm going to pause the video. I'm going to write all the inequality notation for this, and then we'll move on to the example problems for these. Okay, let's try it out for real. Oh, determine the absolute maximum. Well, there's the tallest point, and it's at 7. Determine the absolute minimum. There's the lowest point. This is y values, remember. We do x values for everything else except for this, okay? So when in doubt, x values. Determine where it's increasing. So let's highlight it just so we can see it. I mean, you can't highlight the Chromebook, but just so we can get a visual for it. It's where the graph is going up, where you're making some money, okay? So that's going to be negative infinity to -6, and then 1 to 5. Well, not -5. 1, 5. Okay, and then this one, determine where it's decreasing. I picked this one because of, well, it will be because of this infinity over here. And I also picked this one because we have these, they're called inflections. And it means the graph kind of pauses, but keeps going the same way. Okay, you don't need to show the pause when you're doing this. You just need to say it's all decreasing. Maybe it, you know, caught its breath for a second or whatever, but it's decreasing the whole way. So that is at -5. Remember, on Delta Math, you can zoom in. I highly recommend using that tool because that's going to make your life really easy. Oh, I highlighted the arrow, but that's also decreasing right there. Starting at +5. And again, it is going down. That's why we're talking about it. It's decreasing. But that's not negative infinity. It is just infinity because it's going to the right. Okay. Again, I'm going to pause it. I'm going to write the inequality notation, and then you copy it down and get started on the homework. Email me if you have any questions.